Hi and welcome to the part 2 of performance overview of our system here on Next Day Solar. Today I'm going to present you a few of the systems that we have, and on last video we went in depth on Solis and hybrid inverters and battery storage, and today we're gonna see a bit of PV inverters only and the other brands, for example Victron and Fox and Guawei and Solar Edge. So stay tuned for our video and let's dig in. This project we've installed this year, January. It's a small project and a 6 panels on a flat roof, east-west mountain facing southish. This is a system that is PV only, which means that whatever is generated here at this hour is going to go to the load of the property, and if there is no load, it's going to go back to the grid. And that's because there is no battery to store the energy. So it will be pushing quite a lot back in the summer. So today has already generated 5 kilowatt and it's only 12 p.m. and it's a bit of a cloudy day. So it tells you that this system is performing quite well and quite happy with it. And customer is very happy with this system, and they are actually offsetting quite of their energy because while it's outputting a good amount of energy. For example, it's outputting now 1 kilowatt and the house is only using around idling around 300-400 kilowatt. So right now it's outputting a kilowatt and the house is idling around 400 watts. So it's very good. So let's move on to our next project. So this is a system that we've installed end of March this year. We don't have a video for this project. We have a similar video on a project that already had an existing PV installation there with a fit tariff, which meant the government is paying quite a good amount of money to that property. So we didn't touch that one. We added another one with a battery storage, and it's on a flat roof, on a garage flat roof, and it's only composed of 6 panels. So it's not a lot. It's a 2.4 kilowatt system. So we installed there 6 panels of 410 watt Canadian solar panels, and at this moment this customer is generating 2.1 kilowatt of solar, and he's actually his batteries are 99%, so he's basically pushing back to the grid 3 kilowatt because he already has an existing system. The excess of PV and rather than going back to the grid, it was going to his battery. So the two systems actually are capable of working together as long as there is an excess of PV. This Solis inverter will actually push it to the batteries. So as you can see here, the system has generated so far 506 kilowatt hour of solar, and you can see this last month he has generated 263 kilowatt hour of solar, and we can see his consumption here is 232, and energy from grid was 91 kilowatt hour, and self-consumption was 140. So half of his consumption was solar generated, so which is a great for this kind of a project. So I will move on to our one of our biggest projects, and one of the first one that we've done here at Next Day Solar. It's a 15 kilowatt hour array with 10 kilowatt of battery storage. So in this system we used a very complex Victron system, and Victron is it's very hard to work with, but very gratifying in terms of the amount of data you can get. So this was a system of 44 panels outputting 15 kilowatt. So here we've installed 3 5 kilowatt and Multiplus 2 Victron inverters. We've also installed some MPPTs to actually make sure that the system is quite capable of taking all the load from the PV. And those were 4 MPPTs that you can see here, and you can see the voltage of each one of them. We've separated them in multiple strings, and the battery we've used here are BYD batteries, so 10 kilowatt hour of battery storage from BYD. So here at this time, and this one is live compared to the other ones where you used to see a snapshot of 5 minutes and sometimes 15 minutes. So this one is very, very live. So you can see here the production here is 6 kilowatt at the moment. And it's pushing back to the grid, and it's pushing back to the grid at 5 kilowatt because the batteries are 100%. So all of it is being dumped back to the grid. So this is a really good time for the customer to actually use some of their appliances, because the batteries are 100% and we only are midday. And you can see here an overview of today's production and consumption. You can see that they've used 1.5 kilowatt from the grid and generated so far, and it's only midday, 21 kilowatt hour of solar, and they've consumed 20 kilowatts. So it's been a good consumption and good production so far. It's almost equivalent, so which is not bad. And if we go back to yesterday, you can have a better overview. You can see that yesterday they've generated 35 kilowatt, consumed 20 kilowatt, and consumed 2.7 kilowatt from the grid, and pushed back 16 kilowatt to the grid. So right now we're only in the month of May, and you can see that they've generated so far 35 kilowatt hour just yesterday, and consumed 20 kilowatt and pushed back to the grid 16 kilowatt hour. So you could say that they probably need another battery, and we're gonna talk about that in another video. So what we're gonna do is we're gonna take an overview of the data gathered from last year. So we have here from January all the way to December. So you can see here that the consumption was quite high, and production was, compared to the consumption, was quite low, but it's a good production for that type of system in a month of January. And you can see that consumption is going lower, and that's due to the house having an air source heat pump, and that's drawing quite a lot of energy. And PV is not great in those times of the year, and you can see that that is lower in the month of February and picked up a little bit in the month of March, and April was quite fair because we had 2000 kilowatt from consumption, and 1600 was from PV, so that's quite good. And then you can see immediately in May exceeded the consumption and is lower than the production, and that is being sustained all the way to September. And October there is a minimum difference between the two, and then we go back again into the months of low production, which is mostly from November and all the way to February, and or a bit of mid-March. So that was an overview of last year, and this year you can see that the same trend is keeping up with it. So if we move on our next project, so this is a big project that we've installed a few months ago. So on this project we've installed 24 panels, 410 watt Canadian solar panels. We've used a 10 kilowatt Fox inverter with a battery storage of 24 kilowatt and Fox high voltage batteries. And so far this system has already generated 3000 kilowatt, which is quite a lot. This is 3 megawatt, and it's been really good. And you can see here that at this time of the day is generating 2 kilowatt, and which the batteries are already at 96%, which means that most of the load is actually going to the property. 1 kilowatt is going to the property and 1 kilowatt is going back to the grid. So it's been really a good system. The customer is quite happy with it, and this property has a air source heat pump, so the consumption here is low at this time of the year, and obviously will start picking up when we get close to the cold days. And at this time, and if we take here, and he has generated an average of talking an average of 30 kilowatt hour of solar, and his consumption was quite low, around 12 kilowatt per day. So a lot of it was being pushed back to the grid, and we're gonna see a trend like that all the way to the winter. And so the customer here has a high have installed a lot of battery, and that's because he uses the battery storage in the winter. He charges the overnight and then use it during the day, and then that is actually being adjusted in the days, the summer days, and that means charging less from the grid and using more from the PV. and that's due to the cheaper rate at night, and that's so the more battery storage you have, the more you can charge overnight, and the more you will be using it, and you will be using that battery storage throughout the day and then pay less for it. So that's what this customer has opted for, which means having more battery storage and using that in the cold days, and supplying his air source heat pump and the whole house. And on our next project is basically similar, but we're using here a Guawei system. So here what we have is a 3.6 kilowatt hour inverter. So here the customer has opted for the same thing, meaning he installed 15 kilowatt battery storage. He uses an average of 11-12 kilowatt a day. So that means he charges them overnight and then use that battery storage throughout the day. And it has worked quite well for him. He's saving quite a good amount of money. It's also ecological, and in the days like today, where you can see here that he's generating 500 watt of solar, and the house is only using 278, and the rest is is being charged to the batteries. So you can see here that he has generated so far 501 kilowatt an hour. And the consumption today was 6 kilowatt. He consumed 3.69 kilowatt hour from the PV. So that means he hasn't used a lot from his batteries. He's been using mostly from the PV, and that means that he won't be charging tonight his batteries. So we come to our last project, which was installed a year ago. So this is a very small only PV system. So it's a 1.6 kilowatt hour system, and it has been doing great so far, and it's a small one. It's only composed of 4 panels, so we've used here Solar Edge, and it comes with Solar Edge optimizer with the inverter. So you can see here a nice chart of how it's been performing throughout the year. You can see that here the month of May is quite low because we installed it at the end of the month, and it picks up quite well on the month of June. And then you have July and onwards August, and then you can see a bit of a dip in September, and it goes down from there, October lower, and then almost very low December, and January picks up, and that's the trend with a PV only system and a system of being this size. And what we've noticed also, that a system of this size is quite well pushing back some to the grid regardless. So the house is not using the full load of it. So for example, at this time, and it's generating 1.1 kilowatt, 1.2 kilowatt sometimes, and the house is only using around 300 to 400 watts. So that means the rest is going back to the grid. So at some point this year, we're gonna do a nice retrofit on this project, and we're gonna install some batteries to it, and we're gonna see how this system will actually benefit from having a battery storage and being this tiny of a size. So stay tuned for that video, and thank you very much for watching this video. So this was an overview of some of the projects that we've done here at Next Day Solar, and you will find some of them on our YouTube channel. I will put them in the description below. And if you have any questions or suggestions for any other videos, you can comment down below. And thank you very much for watching the video, and see you on the next one.